Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, you will be learning a topic that is gyroscopic couple. It's a derivation, and you will be understanding what is meant by precessional motion. This topic is the first unit of dynamics of machinery subject, and it is useful for BTech mechanical as well as gate mechanical students. So let us understand in a simplest way. I have developed a model for precisional motion. Let me show this model. Let us understand this. You have a circular disc is mounted on the shaft. I am calling it as the shaft axis is OX, and I have taken this is OY, right? And this is rotating about certain speed, angular velocity omega. It's rotating about its axis OX, and I am making this OX is revolving about OY. So let us observe carefully. I am rotating and I am revolving about OY. This motion is called precessional motion. A rotating disc also rotates. OX is now it is rotating. OX is rotating about an axis perpendicular to it, that is OY. So this particular motion is called precessional motion, or even it is known as gyroscopic motion also. So now let us draw the schematic diagram of this, and before proceeding to the schematic diagram of this circular disc, let us understand the terminology involved in precessional motion or gyroscopic couple. Let us consider OX is on which your circular disc is mounted. So I am just mounting this circular disc on this, and it's rotating in anti-clockwise direction. So it is rotating at an angular velocity of omega. It's about OX is the axis, and rotating about this. And let us consider OY is the axis about which it is rotating. So this OY is called this is called axis of spin, about which it is rotating, and about OY it's rotating as well as rotating about another axis which is perpendicular to it. So OY is called precessional axis, and a body is said to be rotating about an axis perpendicular to it. A spinning body is rotating about an axis. That motion is called precessional motion. And when a body is undergoing precessional motion, it is subjected to gyroscopic couple, and which is exactly perpendicular to both this plane, this XOY plane. So this is what is exactly OZ. Here OZ is called, it is axis of couple, gyroscopic couple to be specific, it's gyroscopic couple. Now let us consider a plane. I am drawing a plane perpendicular to axis of this pin. So I am considering this particular plane, it is vertically downwards, right? And this I am shading with white. A plane perpendicular to OX, that is YOZ. This plane is called plane of spin. A plane perpendicular to OX. So that is YOZ. Plane is perpendicular to OX, and it is called plane of spin. And similarly, let me take another chalk color. I am taking this as green. This particular plane, I am shading it with this. So this, observe carefully, this particular plane is perpendicular to your axis of couple, and this plane is called plane of couple, plane of gyroscopic couple, or simply plane of couple. And lastly, violet color I'm considering, and this is a plane which is perpendicular to precessional axis. So this violet color I'm shading, So see that it is perpendicular to OY. So this particular plane is called plane of precision. Plane of precision. So you have three axes: axis of spin, axis of precision, and axis of couple. And the three planes. These three planes are, plane of spin, and plane of couple, and plane of precision. So these are six terms is known as terminology involved in gyroscopic couple. Now let us understand how to derive the expression for the couple. When you are rotating it like this, it is rotating at a certain speed omega about the axis, and it also rotates about OY. So it will be subjected to a couple acting about a plane perpendicular to XOY. Always it is perpendicular to XOY. It's going on changing. So that couple will be maybe anticlockwise, maybe clockwise, depending upon the direction of the rotation. So that couple magnitude now we are going to derive. Observe carefully. Now let us draw the vector diagram. This is rotating. Let us consider a disk, a circular disk, right? Having a mass of this is OX axis, axis of the spin, and a circular disk is mounted on this. This disk is having mass m and mass moment of inertia of I, and it is rotating in anticlockwise direction. In anticlockwise direction, right? This particular disk, and your OY is axis of precision, and OZ is axis of couple. And let us draw the vector diagram. When you are going to apply right hand screw rule, let us take your right hand and fold the fingers in the direction of the rotation. Now as far as the view is concerned, this is the direction of the view. This is the direction of the view. So with respect to the observer, it is rotating in anticlockwise direction, and the thumb indicates the direction of the vector, angular momentum vector. So let us draw. I am drawing an angular momentum vector, that is OX. The magnitude is I into omega, where I is the mass moment of inertia and omega is the angular velocity or spinning speed of this particular circular disc. So you know the direction, you know the magnitude also. Magnitude is I omega, direction is according to right hand screw rule, it is pointing towards right. Now it is moving in the plane. So let us consider it has changed to new place x prime with an angular displacement of delta theta. So it is in the horizontal plane only. It's moving to the next position, and this next position vector, let us draw a vector diagram, that is x prime, and this angle is delta theta. And that means you are changing the direction from x to x prime, and this is known as active gyroscopic couple. And exactly opposite to this, it is opposite in direction. X prime, X is called reactive gyroscopic couple. Now let us obtain the expression for the gyroscopic couple. So let us calculate the value of x prime, which is the arc length, and it is I omega into this delta theta. And let us calculate the change in this arc length with respect to the time delta t. So that gives you I omega into delta theta by delta t. So if you apply the limiting conditions, it becomes I omega when delta t tends to 0. So this becomes instantaneous values d theta by dt. This is nothing but, observe carefully, this axis OX, the rotation of the speed of the OX axis, it's moving at an angular velocity, and that velocity we call it as precessional velocity I omega into omega p. Omega p is the precessional velocity, omega is the angular velocity of the spinning body, I is the mass moment of inertia of this particular circular disc, and that value I is equals to, it is mk square, where m is the mass of the disk and k is the radius of gyration of the body. And using this formula, you can calculate the gyroscopic couple. Now, the expression is it is represented, gyroscopic couple is represented with C. C is equals to I into omega p. So this is the expression for the gyroscopic couple. Thank you very much for watching this video.